Hi there, this is my fourth video about the Gauss Seidel method. And as I always say, the more, the better. So let's crack on and start with another matrix, and I'm going to show you how to do this method once again. So I'm going to make way more other example in the future, but you know, as I said, I always think that the more the better. So let's start with the matrix 4, 1, 0, 0, 1, 5, 1, 0, 0, 1, 6, 1, 1, 0, 1, 4. There we go. This is our matrix A, as always. So this matrix is 1, 2, 3, 4, 1, 2, 3, 4, so it's a 4 by 4 matrix. Therefore, we're working in the 4-dimensional space, so R4. We could actually have other kind of matrices like 5 by 5 matrix, 6 by 6 matrix, a 27 by 27 matrix. That's 144 times 144 matrix, and so on. So in the 144 dimensional space, and so on, with as many variables. But right now we're gonna just stick with the 4 by 4 matrix, where otherwise it's gonna take forever for me to do all the computation, to compute it, and all the calculation. Okay, so this is a 4 by 4 matrix, and we are working in the 4-dimensional space. Therefore, we have our vector x, which is x made by x, y, z, and w. So the 4 components of our 4 by 4 matrix in the 4-dimensional space. So it is equal to c 1, 7, 16, 14. And therefore, this is just a linear system of equation, which is basically 4x plus y equal to 1, x plus 5y plus z equal to 7, y plus 6c plus w equal to 16, and x plus z plus 4w equal to 14. Okay, so this is basically our system of linear equation. What we're going to do now is basically going to get x, y, z, and w out from those equations. And please note, I'm not going to solve anything. I'm definitely not going to solve anything. I'm just going to get those x, y, z, and w in function of the other variables. So let's just do this. Okay, so I'm basically going to get 4x equal 1 minus y, 5y equals 7 minus x minus z, 6c equal to 16 minus y minus w, and 4w equal to 14 minus x minus z. And therefore we have, I'm going to divide, so 1 over 4 minus 1 over 4y, y is equal to 7 over 5 minus 1 over 5x minus 1 over 5z. Z is actually equal to 16 over 6. We simplify to 8 over 3 minus 1 over 6 y minus 1 over 6w, and w, let me squeeze it up here, 14 over 4, which simplify to 7 over 2 minus 1 over 4x minus 1 over 4z. Let me just rewrite it. This is actually x equal to 1 over 4 minus 1 over 4y. Y is actually 7 over 5 minus 1 over 5x minus 1 over 5z. Z is actually equal to 8 over 3 minus 1 over 6y minus 1 over 6w, and w is equal to 7 over 2 minus 1 over 4x minus 1 over 4z. Okay, so this is basically our system of linear equation. I basically got x in a function of a scalar, and y in a function of a scalar, x and z in a function of a scalar, y and w in a function of a scalar, x, and z. And now we can start our iteration. So let's start with the iteration 1, step 1. All right, as I said, I basically consider iteration to be a full cycle. So to get a full cycle for each and every variable. So x, y, z, and w. Other textbooks may consider it the way I do it or another way. So they may consider each step to be an iteration. It doesn't really matter here anyway. So let's write a table, which I'm going to put here, the iterations, as I always do, and here the values. Okay, so your textbooks may give you, the some initial values to start with, but I basically made up this matrix and this system of linear equation myself. Therefore, we don't have any initial value. As initial value, I'm gonna choose something that is actually really simple. You can choose anything you want. It's just a matter of how fast it's gonna converge to your solution. So I generally choose either to be all a bunch of zeros or a bunch of one. I generally prefer zeros because this way I'm gonna get rid of, everything but the scalars. So I'm basically gonna get this, and this. But you can choose anything you want. So let's suppose that our first guess for the variables are just a bunch of zeros. So x equals 0, y equals 0, z equals 0, and w equals 0. I'm gonna underline them. You should know by now. Why? Well, because it's a first step or the first iteration, so we're gonna find all of them. So I'm gonna write x equal to, well, x is equal to a scalar, which is 1 over 4 minus 1 over 4 times y. So it's actually equal to 1 over 4 minus 1 over 4 times y. But hey, we just said that our first guess, our initial guess for each and every variable is, 0. Therefore, x is just going to be equal to 1 over 4 minus 0, and therefore x is going to be equal to 1 over 4. So there we go, is our first guess for x. So the second guess for x, the first one was actually 0, but anyway, it doesn't really make sense with 0 or so. So iteration 1, step 2. Let's go on and on and on again with this method. So iterations and values. Okay, so now we know that x is probably equal to 1 over 4. This is our best guess so far. But y is still equal to 0, z is still equal to 0, and w is still equal to 0. I'm gonna underline them because we still haven't found them yet. Okay, so y is actually equal to, let's see what the equation was like. Well, a scalar, so 7 over 5 minus 1 over 5x, so it's dependent by x, the x we have just found here, minus 1 over 5z, so it's also dependent by z. So, as we said, y is actually equal to 7 over 5 minus 1 over 5 times 1 over 4, minus 1 over 5 times 0. And therefore, we have that y is equal to 7 over 5 minus 1 over 20 minus 0. And y is equal to 20, 28 minus 1. So y is equal to 27 over 20. So this is what we basically guessed for y. Our best estimation for y so far. So let's go on again, iteration 1, step 3. So now I'm gonna search for the z. Okay, there we go. Iterations, values. Okay, so now we know that x is equal to 1 over 4. We know that y is equal to 27 over 20 because we have just found this. So 27 over 20. But we still have to find z, which is still equal to 0, and w, which is still equal to 0, because we haven't found them yet. These are just our initial guess. Okay, so underlining them. Okay, so basically z is equal to, let's see the equation, 8 over 3, which is a scalar, it's not dependent by anything, minus 1 over 6 y, so it's dependent by y, minus 1 over 6 w, so it's dependent by w. And therefore, we basically have 8 over 3 minus 1 over 6 times 27 over 20 minus 1 over 6 times 0. So 27 over 20 is our value for y, and 0 because, you know, it's still 0, w is still 0. Best estimation for y for w is still 0 because we haven't found w yet. So z, it turns out, is actually 8 over 3 minus 27 over 120 minus 0, and therefore z is actually 320 minus 27 over 120, and this is gonna give us 293 over 120. Okay, so this is actually our estimation for z. Let's go on again. So let's do this whole thing again. We just reached iteration 1, step 4. So let's write it down. Iteration 1, step 4. Okay, so let's write the table once again. Excuse me. So iterations and values. Okay, so now we know that x is actually equal to 1 over 4. Y is actually equal to 27 over 20. Z, we just found z, is this. So 293 over 120. And we still have to find w. So still have the guess, which was 0. So w is actually equal to, let's just check the equation. There we go. So w is actually equal to 7 over 2, so a scalar, it's not dependent by anything, minus 1 over 4x, so it's dependent by x, minus 1 over 4z, so it's dependent by z. So we can use the values of x and z that we have just found. So basically w is actually equal to 7 over 2 minus 1 over 4 times 1 over 4, so x, minus 1 over 4 times 293 over 120. So 293 over 120 is our value, our estimation for z. Okay, so w is actually equal to 7 over 2 minus 1 over 16 minus 293 over 480. Okay, so w is actually equal to, well, 480 is going to be fine. Therefore, we have 1,680 minus 30 minus 293. So w is actually equal to 1,357 over 480. Yeah, those numbers don't actually look good, but you know, I made this up, this problem up myself, so you know, it could be anything. Okay, so let's go on. Iteration 2, and go to iteration 2. I'm gonna do these other iterations, so the complete all the 4 steps of this second iteration. Then I'm gonna stop, and I'm gonna go, you know, I'm not gonna go any further with this video. So step 1 of the iteration 2, basically gonna do this again, over again. So iterations and values. Okay, so we now know that x is equal to 1 over 4, y is actually equal to 27 over 20, z is actually equal to 193 over 120, and w is actually equal to 1,357 over 480. Okay, Okay, so we're basically going to get x. X was 1 over 4 minus 1 over 4y. So it's dependent by y. So x is basically 1 over 4 minus 1 over 4 times 27 over 20. So and guessed our estimation for y. So x is actually equal to 1 over 4 minus 27 over 80. So x is actually equal to 20 minus 27 over 80, and therefore x is actually equal to negative 7 over 80. Okay. Oh, I'm sorry. I forgot to say that I always underline because I always reload. We just started with the first step of the iteration 2. Okay, so iteration 2, step 2. Okay, so let's do this. Iterations and values. Okay, so we now know that x is actually equal to negative 17 over 80. Y is actually equal to 27 over 20. Z is actually equal to 293 over 120. And W is actually equal to 1357 over 480. Okay, so we're basically on underlining those three guys, Y, Z, and W, because we haven't found them yet for the second iteration. Okay, so Y is actually equal to, let's see the equation, is actually equal to 7 over 5, which is a scalar, minus 1 over 5x minus 1 over 5z. So we're basically going to have 7 over 5 minus 1 over 5 times negative 7 over 80 minus 1 over 5 times 293 over 120. Okay, therefore we have y, which is equal to 7 over 5 plus 7 over 400 minus 293 over 600. So y is actually, oh god, is 1200. So is 1680 plus 21 minus 586. So y is actually equal to 1115 over 1200. I can't really blame anyone but me, because I made this problem. So I gotta work with those values myself. So even though they're not pretty. Okay, so iteration 2, step 3. So iteration 2, step 3, let's go on again. We're almost there. We're almost there. So iterations, values. Iterations, values. So now we know that x is actually equal to negative well, I'm sorry, I made a boo-boo here. X was actually equal to 7 over 80, not 17 over 80, and 7 over 80. But we're lucky. I just substitute the right one. I basically made a boo where I read 17 instead of 7. But this is fine. I actually substitute eventually could substitute the right value. Okay, so x is actually equal to 7 over 80. Okay, so x is actually equal to 7 over 80. We know that y is now equal to 1115 over 1200. Z is the old value, so 293 over 120, and W is the old value, so 1357 over 480. So those calculations now are not gonna be easy. Okay. So now we're looking for Z. Let's take the equation and cross our fingers. So 8 over 3 scalar minus 1 over 6 dependent by y minus 1 over 6 dependent by w. So Z is actually equal to 8 over 3 minus 1 over 6. 1 over 6 times 1115 over 1200, which is our best estimation for y, minus 1 over 6 times 1357 over 480, which is our best estimation for w so far. Okay, so Z is actually equal to 8 over 3 minus 1115 over 7200 minus 1357 over 480 times 6 is 2880. Okay, then Z is actually equal to, sorry if I'm, between those three is 14,400. Therefore, I'm gonna have divided by 3 multiplied